Hi, everyone. My name's Eric with Bobcat, and I am the demo technician with Bobcat Cam. So I do demonstrations of the software program for potential customers. I do uh, tech support. So if there's any questions, we're open Monday through Friday, 8 a.m. to 5 p.m. Eastern Time, and we can log in, answer any questions that you may have, individual questions like that. If you'd like to schedule training, we offer online training. And again, open Monday through Friday, 8 a.m. to 5 p.m. Eastern Time. Um, and we record the training hour or a 2-hour session and send you the recording for you to review later on. So we'll take a look at BobART today. I have this part file in a Google Drive link in the chat. Now, if you're not viewing live today, you might not be able to get to the chat. So that's just sort of a benefit to being able to view the live chat or the live event today and being able to follow along with the part file that I have here. So basically, the only thing I did in BobART for this was I created the vectorization of the American flag. If I don't have this as a DXF drawing, I can go to the internet, which is on my other screen. I'll move it over here. Alrighty. So we have the internet. I Googled American flag. And I went to images and I downloaded the American flag from Etsy. I think it was this one right here. Right click on this one, save image, and so I save the image to my downloads, and I then go to Bobcat. I go to a new file. I can go to BobART, which is down here at the bottom left corner. If your BobART tab is pinned to the side, you might see it on the side of the software program on either side. And under BobART, I can go to images, and I can right click on images and go to load image. Then I go to my American flag image, this one here, and hit open. And I'll go back to what I have here for this one. Then you'll see right below images in BobART, you'll see image dash download 2 is the file name that I downloaded it as. If you named it American flag or named it whatever file name, it will say image dash file name. You right click on that selection and go to vectorize, the second option down. This is where you can move the slider bar, and I'm going to hide the drawing that I had. Okay, so here's the image that it brings in, black and white. And when I zoom in, I can see the stars are pretty grainy. The image just itself is kind of sketchy. So I can always modify the drawing after the fact. That's what we'll be doing after this to look at. We go to this slider bar over here. And when I go too far to the left or too far to the right, you can see that everything sort of becomes even more pixelated. So I want to get right in the middle here to find the best vectorization that there is. And the reason why we have this threshold value option would be because if I have an image with a foreground and a background to it, if I go to the left or to the right, on one side it'll have the vectorization for the foreground. On the other side, it'll try to vectorize the background of the image. That's basically what this is for mostly. But then once I get a good enough image here, I click OK. And I'll put it on a new layer here. And you'll see the vectorization that it creates. That is on this layer as well, I believe. Nope, that's gone now. Okay, so here's my vectorization. And here are the stars. So there are a couple different ways to modify this pretty well. You could go to utilities, drag corner, and deform. Now I'm just going to do one basic star here. I'm going to recreate the star a different method than this, but just to show you, the drag corner would be if I wanted to drag this corner down over here and drag this one to the top, I could do that. and I want to change the curvature of the arcs here as well. I want these to be straight lines. That would be our deform function, the next option down, where I can change it like this. I could break the arc at this location and then drag a corner out like that. I can also, you can see with the arc, it's trying to lock on to construction geometry, different reference points here. It's also very choppy where it's going to move every 16th of an inch. And the reason for that with our deform is because we have our snap increment option down at the bottom right here. So the snap increment option of a 16th of an inch will mean when I go into any CAD function and I move my cursor, it's going to move over every 16th of an inch. So if I turn off that magnet icon, you can see it's a much more free-flowing option here to be able to modify what you need. Okay, let me go back to... Let me go back to the chat, see if you guys have any questions so far. If you have any questions, please let me know, and I will be more than happy to answer them during the live event. So when I recreated my stars, this one's pretty easy because we go into Create 2D, and we go to the Shape Library. And in the Shape Library, under the drop-down here, there is a star. And I can go in and sketch it right here where I want it to be. I want it to be smaller though, so I go over here to the dimensions and let's make it 1.5 inches instead of 2 inches. And then I can fill up my sheet, you could say, with all of the stars by going to Utilities, going to Translate, and I'm going to chain select the one star, move it over in the X direction. I'm just going to guess 2 inches. And it looks more like 3 maybe. And then to get it more exact, I can type in the translate amount here of, instead of 3 inches, change it to 3 1/4. Let's change it to 3 300. Oops. 3.300. That looks good enough. And then I can go to copies and then make 1, 2, 3, 4, 5 copies across. And then I select all of those stars and translate them down, making 1, 2, 3, 4 additional copies going down. And then I have to get those stars in the middle as well. So that's how I recreated the stars to make it look like this instead. And then, so after that, that will be my 3D modeling portion of it with the stars and the stripes here. I went to Extrude Boss and I extruded it up to make it sort of like a piece of stock there. And then, after my first Extrude Boss, I went on to the front UCS and I sketched a spline to make that waviness of the extrude cut. So if you can imagine, I'm doing my Extrude Boss up, which is, very basic. I have a border around my shape where I extruded it up. I then did an extrude cut across. So I go to my layers, and under my layers I have bottom and top. That will be, so the top will be the extrude cut to cut the top of the stripes here. Bottom was the wireframe that I used to cut even lower, to cut away from that. So I did an Extrude Boss, I did an extrude cut with the bottom wireframe. I had to make the bottom and then I could extrude it up further after. So then I did an Extrude Boss, and my vectorization was this selection here of this second Extrude Boss. So I know I'm kind of jumping around a little bit, so I'm going to take it from the top again. I went to BobART. I vectorized an image to make it this here and modified the stars to make it look nicer. Then, I know I skipped this step last time. So after I've done my vectorization, I made a border for my original Extrude Boss. So I went to Create 2D, and I just sketched some lines going across here, and then I offset it 1/4 of an inch all the way around. And that would be my border here. So this is the border that I created. These first 4 lines on the inside were just going to create 2D line and going point to point, clicking on each endpoint there to create the original border. And then I offset it to make a border on the outside there. I extrude cut that outside border. I extrude boss that outside border for my first extrude boss here in the cat tree. So that is under the border layer if you're following along with the Google Drive link part file. Next, I did my extrude cut with the bottom wireframe. And again, I just went to a front UCS. I went to create 2D and I went to spline. And I've created a bunch of points here to create that wavy look with a spline. And then I closed the shape up, you can see here, after I made the spline. I made a couple of vertical lines, and then from the 2 endpoints at the end, I made a line going horizontal across to sort of make this block shape so that I could cut this block out of my original extrude boss here. So if I look at it from a front view, here's my original extrude boss. Here's my extrude cut that I'm cutting away from. Then I'm adding more to my solid here, because my original extrude cut down to here. Then this is under my technically vectorize in my stars layer. And this is my wireframe to use for my second extrude boss here. And I went pretty far up. It can be pretty far up just based on how you have your top wireframe here. As long as the top wireframe is, this horizontal is high enough, I'm cutting away everything in excess above this level here. So that's why I made this second extrude boss going up 6 inches. My height of my part here of the solid is only 5 1/4. But I want to make sure I'm going up high enough so that I have all of the stock that I'm creating to cut away from with my second extrude cut for the top stripes here. And that is how I created this 3D model. So not a whole lot being done with BobART. It's really cool to be able to vectorize something, so that's why we saw that option here. To be able to start with, if you don't have a drawing of this, you just find an image online, use BobART to vectorize. And then maybe we want to do the emboss here. Let's start with that. Okay, so if I have my stars, oh, here we go. Turn off stars. There we go. So then I'm just going to my select mode, deleting out the stars that came in originally, because I wouldn't be using those. I'd be recreating them like this. Now we can create an extrude boss in our I'm sorry, not an extrude boss, an emboss in our BobART page. That's going to be the next step here. So we could do it with this one. You know what? I'm going to do it with a different file. So we're going to go back to the internet. And then our next file here, American flag. I'm going to type in, I do this one a lot, Tampa Bay Lightning logo. We're here in the Tampa Bay area, so we are using this type of logo here. Let's do this one here. Let's see if I can save the image. So the first image you find, you can save it as a PNG. You could save it as a JPEG, any type of file format you find online. You can install it onto your computer. You can go to BobCAD, and in a new file, you can load an image, and you can find the file type here. So I'm going to find PNG, and it's going to be this one here. Let's make it in the X direction. Let's make the X size 4 inches, and it will keep the aspect ratio. So the Y size is 3.5. So that way it doesn't stretch on us. It lengthens the Y size as it lengthens the X size with this keep aspect ratio option. I could turn that off and maybe make it a little bit shorter if I wanted to, but it'll stretch the image there. So I'll click OK. I'll right click on image, download to, and go to vectorize. And then I'll move it over far enough to what I need and click OK. And then I can blank out the image so that I can see the drawing better by right clicking on the image file, download to, and going to blank, unblank. So it's a little rough there, but again, I can go to my deform, zoom into these arcs here and make it look a little bit nicer, at least to start off with. It depends on the tolerance level of the machine too, to even see if there's any issues that we'd be seeing here, or if this is just as good as the tolerance level of the machine will get anyway, where you don't have to modify too much of it. But once you have the drawing that you are working with, you can go to BobART, and then below vectorization, you have emboss model. So I'm going to right click, and every time I go to emboss model, I'm always trying to remember second option down, edit canvas. I'm always clicking on that one first, because whether you select your emboss regular, your emboss swept, emboss to rail sweep from image, all these options, it's going to bring you to this page first anyway. So just to remind myself of the workflow in the emboss model function, I right click on it, go to edit canvas, type in my X size and Y size of the stock that it brings in, or the canvas size, and you have your base height here, which is the thickness of the stock or of the canvas that it creates when you click OK. And then you can emboss it by you can emboss the canvas from the drawing that you have by right clicking on emboss model and going to emboss regular. We're going to start with the first one here. Emboss regular, select my drawing, and scroll down here, and this graph here is basically if we were looking at it from a side view. This is how it's going to sweep the surface that it creates. So I could change it from a convex arc to a concave arc to a line, which would be just like an emboss with a tapered angle, convex, concave ellipse, and I usually use spline because then you have these 3 points that you can change for your specific creation there. There we go. And then I'll click OK. And then when I look at it from an angle here, you can see what it brings in as. Now, it's adding to the canvas of 1 inch thick. If I want to go down, I can go back to the regular emboss here, right click on it and edit. And up at the top here, instead of add, we have subtract. It will create the negative of what we just made there. And the depth we'll find in that regular emboss. When we go back to edit, at the very bottom, we have the, is that it? The Z scale. So if I change the Z scale to, right, is that right? No, well, there's base height, and then there's the depths here. So the depths here you're seeing at about 1/4 of an inch. So if you wanted to change the peak to like 1/2 an inch and click OK, you'll see it going deeper down. So that's what these numbers correlate to. The y-axis is your depth. So we're looking at about a 1/2 inch deep there. If I scroll down to base height, so if I type in 1/2 an inch there, you can see it starts with straight walls and then it does its emboss from there after a 1/2 inch down with your base height option here. So maybe if you want, a step down of 1/8 of an inch, and then it does its emboss. Now you can see the side walls are a little bit rigid or, shaky there, and you have tight corners in here which would be impossible to finish up. So to smooth it out, we have a smoothing tool. You can right-click on Emboss Model, and down towards the bottom, actually at the very bottom here, you have your blank and unblank, so you could hide the emboss or show it. When I right-click on Emboss Model again, I go to Smoothing, the next one up. And here's our smoothing window size. This is basically the strength of the smoothing tool. So if I click OK, you'll see the sidewalls smooth up pretty well there. But down at the bottom, still kind of some tight corners, so I could go back to that smoothing tool. It's going to be labeled as Smoothing 2, because it's going to number it as every emboss function in here. Your regular emboss was 1, your smoothing tool is 2. We'll get into another tool after this. But the smoothing tool, I right-click on it and go to Edit. And I'm going to change this. I'm going to double the strength of it, you could say, from 50 thou to 100. So instead of 0.05, I'll type in 0.1 and click OK. And now you can see it's even smoother there. So that is a great way to smooth out your emboss after you've created it. If you want to focus on, let's say we want to focus on this little vertex right in the center here, and then going down, if I want to focus on this area and smooth it out even more, I can right-click on Emboss Model, and then I go to the option above Smoothing, which is Sculpting. Click on that, and now for this one, I'm going to look at it from a top view. So I'm going to click on this icon for a top view. Okay, click on Top View, and then you can see, here we go. So method, you can see the name of the sculpting operation is Sculpting 3, and then just down below that, I always click on Smooth. And you can see when I move my cursor around, this is our smoothing tool, this one that we're specifying at a certain location where to smooth it at. So I can change the diameter of that smoothing tool here. Let's change it from 1/4 of an inch. Let's change it to 2 inches. You can see how large it is. I'm going to change it back to 1/4 inch. And then the strength of the smoothing tool here. So when I click down and hold on if I left click and hold and move my cursor into this area, and then I let go, it smoothed all of that area, and I can go back across again. It smoothed it a second time. Click and hold a third time, click and hold a fourth time. Now, we can see it's a little bit smoother. I can change the strength of it. You saw with that original smoothing tool, 0.05 wasn't very strong, so let's go to 0.2 and click and hold. Now I can see the strength of the smoothing tool actually sort of messes up the emboss there afterward, where you can undo your last operation. So I'm just going to get rid of all of those times I've tried to smooth out that area there, and then click OK. So that's the smoothing tool, that's the sculpting tool. Then we'll be getting into from emboss regular, emboss swept, emboss 2 rail swept. These are for different methods on how to emboss like this. This one just goes from the outside and goes straight down. We have some example files. If you go to File and go to Help and go to Bobcat Cam Help, there are some getting started pages in there on how to create some other emboss functions with those. But I almost never use those. The other ones that I use in um, the other ones that I use in BobART would be emboss from image, and we'll finish off with emboss from solid or component, which is STL file. So we'll start with emboss from image. If I have a really bad image and it's almost impossible to vectorize, or maybe we've got some colors in it, a whole lot of colors that we need to emboss from. Let's go to, you know what, I actually did this yesterday, so I'm going to find a coat of arms for a family. And this is just an example one. I'm just finding this from Wikipedia. I'm not getting the one from yesterday, so don't worry. Let's see what we got. Let's do this one in. Let's do the seal. Let's do the Great Seal of the United States. I hope I don't get in trouble for this. So let's right click on the image, save image as, and it's a PNG file. And I hit save. So this, I just went to coat of arms, and then I scrolled down on the first Wikipedia page, and I found this seal of the United States. We go to Bobcat again, go to a new file. Now, the first one I'm going to do is show you how it would look if we vectorized it. So if I go to BobART, right-click on Images, Load Image, I can select that. Where was it? It's a PNG file. Right here, and this one here. Now, if I change the size here and then click OK, and then try to vectorize, you'll see it actually does halfway decent with the black and white like that. But if I want to go in further to try to get all of the vectorization of the feathers there, and then try to get the profile of like the seal at the top here and the profile of the bird, of the eagle there, this is what it comes out with. So not perfect, but there is another way. So if I blank all of this out, I'm actually going to go to my select mode and just delete all of these lines and arcs that I created with the vectorization. Down here, I'm going to go to Emboss Model. I'm going to right-click and go to Edit Canvas. I'm going to make it 4x4 because the seal was something like 3.5 by 3.5. And then I'm going to go to Emboss from Image. I'm going to load an image right here with this button. And then I'm going to select that PNG file. I hope this looks halfway decent. There we go. Not looking too bad. So again, we would just smooth it out for the straight walls there, and getting into, you know, it looks a little grainy here, but then we smooth it out and it looks a lot better. What else do we have? Again, this is adding to it. So if I wanted to do an engraving of this, I would just change it from add to subtract. And then I would right-click on Emboss Model. I'd probably just go to Smoothing and start at the default 50 thou, and that looks halfway decent. And then if I were to, let's go 0.75, and then makes it even smoother. And you could rough this out and follow it along with a ball end mill or a tapered tool in 3-axis from there. That's what I did in the American flag file as well. You can see we're doing 4th of July themed already. It's almost the end of June. So we've got that great seal of the United States. We've got the American flag. where I created the solid from it. And then I went to the cam tab up at the top and created a new job from there. And I went to my machine, BC3X Mill, as the Bobcat 3Axis milling machine. I defined this as my workpiece. Next page, I defined my stock. I just left it at about 3 feet by 5 feet, and the Z depth there actually doesn't look like 3 feet by 5 feet for my dimensions, but that's okay. What else do we have? It all depends on the size of the stock that you have of wood here anyway, right? So we have our milling job, we have our stock, and we have our machine setup. That was that last page in the cam tree after the stock definition. This is where you're defining your work offset. So this is a good example because I have this part file somewhere out here in space. The work offset starts here at the CAD origin location by default. So I could move my part over to the exact location that I want it to be, but I think it's easier sometimes to just go to the machine setup, go to origin, and then click on this corner, and that's your new G54 work offset in the G code from there, separate from your CAD origin location. So you don't have to translate it down. You don't have to rotate it around to do any drilling on the bottom side of it, for example. It's all done in the machine setup page there. All right. Let me see if you guys have any questions so far. Looking good. Okay, and so we're back on the American flag file here, and I did an advanced rough, I did an advanced planar, and an equidistant toolpath. Now, why is my toolpath all the way up there? I would imagine it's because I moved my stock, my machine setup, my geometry was reselected. I really don't want to close out of the part file because I have my simulation open. So let's just see if simulation runs correctly. Oh, you know what? I think it was from the machine setup. Let me drop it back down to where it's supposed to be in this file as an example. Okay, perfect. Now that's a great thing we just saw too. If I change my machine setup where it is currently at the CAD origin location, but if I've done all of my milling operations and I want to change the G code to reflect my new machine setup, I can right click on machine setup 1, edit, click on origin, and click on this point here, and click OK. Then you'll see the toolpath is shifted because it's still trying to reference my original machine setup. So what I have to do is either right click on each feature, go to update all geometry and compute all toolpath here, or I can do it for the whole milling job by going up to the top right here, update all geometry, and update all toolpath for all of the features. And then you'll have your toolpath looking more like this. There we go. So here's our advanced rough. Here's our advanced planar toolpath and an equidistant toolpath. This is what I thought might be the best, but after I thought about it for a little bit longer, I like the roughing here, and then the planar toolpath, not so much. I like the equidistant. The equidistant's a really good one where it's, I selected for my boundary of the equidistant, you can see, I selected the stars and the vectorization. So that's my boundary that I selected. So it creates the toolpath offsetting from each star to the rectangle and just offsets its way out. It's a really good toolpath there. Then the planar toolpath, it went all the way across and it dipped down into the bottom stripes as well. What I'm thinking about now would be changing my boundary for the planar toolpath here to be, let's just focus on the, I would say, let's focus on the top stripes first so that it planes across the stars and the top stripes, and then come back and select my boundary as inside of the lower stripes, and then do a planar toolpath with that, just sort of specifying, just sort of specifying the toolpath to separate them out from the top surface here to the bottom surface. That's what I would do if I were to modify this any more than I already have. But in the feature, you'll see that the first tool was a 7/8 tool, pretty large depth of cut and step over, leave an allowance for a finish pass to clean up. I left everything else by default there. The only thing I changed was the tool, other than versus what the default settings normally are. Then planar toolpath, I did an advanced planar with a 1/4-inch ball end mill. And the only thing I changed here was the angle direction of 0 degrees will go back and forth along the x-axis. If I change it to 90, you would see it would change and go back and forth along the y-axis. I can do anything between 0 and 360 here as well. I could change it to 45, and it would do a 45-degree angle cut diagonally across the part. So sometimes, especially like with woodworking here, you could do 0 degrees run across the x-axis, and then you could do another planar toolpath at 45 degrees, and it'll cut at a different it'll cut in a different direction so that it goes sort of like against the grain from the original 0-degree angle. Give you a much better finish that way. Other than that, I left everything by default for the planar toolpath. For the equidistant toolpath, I have an 1/8 inch angled head there, or an angled tool with a taper of 8 degrees. What else do we have? Direction of the cut. Step over, I changed from 100 thou to 10 thou because this is a very detailed finish operation here. And the only other thing that I changed in the equidistant from the default options was this 3D extents option. You can see it starts at extents where the center line of the tool will end at the edge of the part, and you can see there would be some material remaining here. So the 3D extents will sort of overflow there with the radius of the end mill to finish any areas that way. And that's the only thing that I changed there. Now we'll look in our simulation. You'll take a look at the feed rates in each operation. We're at like 100 inches per minute for the cutting feed rates, down to 60, down to 50 for the finish operations. And our cycle time says 14 hours. So this would be an all-day event, even if you tried to cut down on cycle time to maybe speed up the feed rates for the finish operations, change the step over if you don't need the finish part to have such a detailed surface finish. But you can see every depth of cut here for the roughing. I can hit pause and just hit next op up at the top here to get to my first finish operation, which will be our planar toolpath. Just run across it like that. Now, obviously, there's probably too much material to try to do a planar across with this. We might have to do another sort of like a semi-rough or a semi-finish operation before we get to this finish pass, but this was just an example I thought to whip together before the webinar today. And then here's our equidistant toolpath, following along each star and then offsetting out to the outside boundary there. That's at a step over of 10 thou. So this is our operation that's taking about 8 hours of our time here. So if you don't want it so detailed, maybe you could change the step over back to like, I don't know, somewhere between 50 to 100 thou, and then you'll have a much better finish anyway, whether you set the step over to a number like that, you'll still have a good equidistant toolpath. And so after this is done, we can see the finished product here. And we can also go to the bottom left. Now that's where I am at the moment. So let me move myself here. Okay, should be able to see me up at the corner now, at the top corner of your screen of this video. And so now you'll see at the bottom right corner of our simulation here, there's a drop down under this analysis tab. And in this drop down, none would just leave this blue color for my stock. Tool number will change the colors depending on which tool has machined the surfaces here. So you can see yellow was where we roughed it, green was where we used the planar toolpath, and blue is where we used the equidistant toolpath. So you can see if I look into this area, some of the roughing was where we last left off with this star. Some of the green here was where the planar toolpath left off, and the blue is where the equidistant toolpath came and cleaned up more. If I change the tool number to operation number, it'll change the colors to the operation it's machined that surface. And then the next option down is the one that I frequently use. That's our deviation report. And I can hit refresh next to deviation. It will load different colors on our stock depending on how much material is remaining to get down to. And you can see here in green, you can see this is really a really good equidistant toolpath there. I keep saying that, I know, but it actually looks really good. The planar toolpath looks okay, but we can see in green, all of this in green is showing that it's cut to size with a cut tolerance of plus or minus 8 thou. If I zoom into the top of the stars and the top of the top stripes here, even the bottom stripes as well, you can see at the peaks, it's this teal color, which is saying there's somewhere between 8 and 26 thou remaining in this color here, in the dark blue into these corners of the bottom stripes that it couldn't fit into well enough, showing there's more than 60 thou or 64 thou or more remaining with that dark blue color. So we could use a smaller tool to fit into the corners a little bit better, but it's a great verification tool to make sure everything is cut to size before we run it on the machine. And then I'll click close out of the simulation. And that is it with the vectorize, emboss, and how to create a toolpath on a BobART file. You know, it's exactly the same as if we were doing it from an extrude boss like this one. You go in and create a new job and select this as your part that you're machining there. We did the emboss from image, and then we're moving on to, here in BobART, we're moving on to emboss from surface, solid, and component. Emboss from BobART surface, it would be one that I've already created in BobART. So we're going to focus more on either a solid or a component. And the main topic of this webinar is going to be emboss from component, because that's an STL file. So I'm sure if you guys have worked in the with STL files before, that you're familiar that they are not nice to work with. They don't have surfaces. There's no solid to it. It is considered technically to be a triangular mesh file. So you'll have a lot of issues with trying to extract edges to create wireframe from any edges, because there are no edges in an STL file. You'll have trouble trying to extrude cut anything away from it. You can add to it and then save it as an STL file again, and you can keep adding more to an STL, but you can't take anything away. You can't extract any edges to create like an imprint of it, is what we're going to be going through. So we'll take a look at that. We'll go to, and I think that's going to be like the main point of why we would want to emboss something from an STL file that's already embossed, if we need to manipulate the size of it. So we'll do that here. Right click on emboss model. And again, I'm always going to edit canvas. And this file that we're working with, trying to emboss it, this is Horace I am not well read on my Egyptian mythology, so I'm not sure what Horus did or who he is, but we've got this file to start from. So this is the one we're starting from, this model, and then we want to get the imprint of it. Let's say, we're making the mold for this figurine here. And so I think I'm just going to go to a new file here. Okay, so I'm in Bobcat 5 now. I'm in a new file. I go to import the STL file first. I want to see how that looks. So I'm going to go to File Open this Horus STL file, and I'm opening it in millimeters because that's how it was created. We came up with this import option to scale it from millimeter to inch very easily because STL files, when you're translating from one CAD software program to another, translating it to a 3D printer, sometimes the scaling's off between millimeter and inch. In this case, if I change it to inch, it's 300 inches tall. So don't want to do that. We want it to be more like 300 millimeters tall. So I'm selecting millimeter, and here's the shape there. And in inches, that's 11.5 by 3.25. So we'll say 12 by 3.5. And so, or 3.5 by 12. So we have the STL file, and we want to create an imprint from it, basically. And to do that, I'm going to go back to Bobcat 5. I'm going to go to BobART. I'm going to right click on Emboss Model, and I'm going to go to Emboss from Component. I'm going to type in, well, there we go. We're back to the canvas selection. So I'm going to type in 3.5 by 12. And I'm going to leave the base height at 1 inch there, and then click OK. I might have to do more, actually, because what was the STL file? If I want to find out the size of it, I can right-click anywhere in the CAD workspace, and I can go to Entity Summary halfway down, and it'll tell me X, Y, and Z size. That's about 4 inches tall, including that base for the figurine. So we're just going to start with 1 inch and see where that gets me. I created the canvas from Edit Canvas, basically 3.5 by 12 and 1 inch for base height, and I can change it there at any time. But my next one is I'm going to go to Emboss from Component, Load Component File, which would be loading the STL file here. Oh boy, we've got. Oh, here we go. So it brings in the large 300 inch size here, but I can change that number here. I'm just gonna type in 3.25 by 11, almost 11.5. There is what it scales it down to, and then I will click OK. So it just adds to it. I want to subtract from it to make the mold here. So I'm going to right click on the component here, edit, and change it from add to subtract, and click OK. Now you can see 1 inch isn't going to do it well enough because it's dropping further down than the 1 inch there. So I'm going to right click on Emboss Model, edit Canvas, and let's make the base height, let's go 5 inches, and click OK. And then now I can see, wow, the base height is way too far down that I typed in. So I'll go back to Component 1, Edit, and base height. Did I have a base height? I don't think so. Oh, I think it's the Z depth. Yes, that's right. So the Z depth is from the top and going down this 3.8. And so if I want to sort of flatten it, I can click on keep same ratio. So I can uncheck that keep same ratio. And I'm just going to type in 1 inch here and click OK. There we go. And then again, with the straight walls, it's a little jagged, so I can right-click on Emboss Model, Smoothing, and I'm going to go to 125.125 for smoothing window size, and it will smooth things up. Now this, you can see, is the front face of this guy from my STL model. Let's say I want the other side as well for the mold. I can right-click on Component 1, Edit. Well, here's our subtract. If I scroll down to the very bottom, we have this invert option to change the emboss from the top side of the figurine to the bottom side. So I just check this box inverse or invert at the bottom and click OK. And now you can see this is the back of his head right here instead of the front of his head. So you've got your one STL file there. You could hit save as and save as, the back side. Come back, turn off invert, and click OK. And then save this as top side, and you've got both of your files that you can create a 3-axis roughing, an equidistant toolpath, and then a pencil mill to follow along all of the curves in here with the correct ball end mill that'll fit in there. A lot of good stuff there. If you guys have any questions with the emboss from component from an STL file to get a mold shape like this, the mold of this figurine, let me know if you have any questions with that workflow of creating this emboss from component. We went over emboss from image. I imported an image like this one here, just imported it right into BobCAD with the BobART function to create the emboss of this. We created the emboss from the vectorized drawing. We vectorized the drawing and created the 3D model in the CAD side of it. And that's about it. So yeah, those are the big ones in BobART. You have your vectorize, you have your emboss regular, emboss from image, and emboss from component. The sculpting and the smoothing tools we went over as well early on in the webinar today, and those are great to be able to change your original sort of emboss with jagged edges like this here and be able to smooth those side walls out and things like that. And you can right click on a tool and suppress it or unsuppress it and regenerate to regenerate the smoothed surfaces there. So yeah, if you guys have any questions with what we've gone over today, please let me know. And I'm more than happy to answer anything else that you have in the BobART functionality here. And I want to thank everybody for viewing the live event today. We went over a lot in BobART. The main focus was this emboss from component. We went over vectorize, went over emboss regular, emboss from image. If your vectorized shape is, not clean enough to vectorize, you can always go to emboss from image as well. That's my next go-to to troubleshoot with that. Then your sculpting and smoothing tools to smooth out your embossed file from there. And as we mentioned, we have a toolpath in these files, so you can see that you could use your BobART is called art model when you select that as your geometry in 3-axis milling, and it allows you to create toolpath based on the STL file there, the BobART model. which is technically sort of considered an STL as well, because this is triangular mesh, just like an STL file. All right, cool. I don't see any questions from you guys, so I hope you guys enjoyed the live event today on BobART, creating an STL file or creating an emboss off of an STL file from component. And we will see you in the next webinar. Today is June 25th, so we have webinars every other Wednesday. So our next one is going to be July 9th. We don't have a topic yet on yet for our next webinar, just because we send you guys a survey out and make sure that we are doing these webinars specifically to what you guys would like to see. So this one was on BobART. Last week was on the advanced user interface in 3-axis milling. So whatever you guys would like to see in these webinars, let us know in the comment section in that survey, and we're more than happy to tailor these live events to exactly what you need there. And thank you again for everyone viewing us live today, and we hope to see you next time. July 9th will be our next webinar. Thanks again. Have a great day.